Hi folks, my name is George Choquette. I'm the Electric Power Education Manager at Applied Professional Training in Carlsbad, California. We're here at the Imperial Irrigation District to teach 3 classes in advanced smart grid, wind energy, and those types of things. The first class is going to be PC375, and it's the telecommunications reliability effects on power grid operations. Next class is going to be smart grid transmission and generation. Last class is going to be wind dynamics on power operations. Now this is very important because we all want renewables, we all want solar power, and the problem is these are intermittent sources. And when the wind blows good and steady, that's great, but sometimes it's intermittent, solar cuts in and out because of the clouds, and it's having a big effect on the power operators. That's what they're learning today. We have our instructor here, Mr. Bill Ackerman. He's got about 40 years experience in the utilities business. We got him all set up with his binder. He's got all this stuff for the students. The exams are in there, I think, and we're all ready to go. So by the way, we can teach any of those classes anywhere in the world. You can be out in Kuwait if you like our classes. We can send our instructor there, and we can also do this by webcast. So please give us a call, check out our website, aptc.edu, and let's go see how Bill is doing in a class. Thank you.
This course is PC375, where we're going to discuss all of the characteristics of wind and how it impacts power grids. So we're not going to really design a wind system so much as we're going to talk about how wind impacts an existing power system. We'll start out talking about some statistics about where wind is at the present time, where the power utilities thinks it's going, and where the various authorities would like to see it go. Then we're going to move on to some types of wind machines. What kind of systems can we put up, from single blade to multi-blade and tower mounts and that sort of thing. All the different ways where it might be possible to convert some wind energy into electrical energy. After we look at the most popular of those, we'll look at some measurements. The kind of measurements you have to make before you decide you're going to build wind, because if you're in an area with very little wind, certainly it's not going to be worth spending the money. On the other hand, if you're in areas with a great deal of wind, that's going to determine what kind of a wind energy system you can use. After the measurements, then we look at some of the technology that's currently available, and also try to look a little bit into the future to see where developments might be as to what kind of technologies are coming along and how they will impact into an existing power system and how the power system may have to adjust. After the technology part, we're going to look at power system interconnection. All of this wind equipment is supposed to fit into an existing power system. Remember, your existing power system was designed for a fairly stable, fairly slow changing characteristic. In other words, customers do not all of a sudden everybody turn on their lights. They start turning them on as it starts getting a little dark. Finally, when it's totally dark out, all the lights are on, but they did not come on all at once. Whereas wind is a whole different system. Wind can come and go very fast, and that can cause problems with the operation of the power system, and how existing generators, which relatively speaking are very slow responding, how are they going to fit in and operate in conjunction with the wind systems, which relatively speaking respond very fast. So the method in which we interconnect these different types of generation into the power system going to have different cost issues and different performance issues. Performance issues is how do you adjust the power system for the variability of wind. We know that wind can go from 0 to as much as 150 miles an hour in a hurricane. It can make that change very slowly, it can make it very fast. And the way in which the wind changes and the amount of generation that changes will impact how the power system responds. And if the power system does not respond properly, you can either get variable frequencies which are not good for the power system, or in some cases you can actually cause the existing protection schemes to shut down the power system. Instead of adding to the reliability and capability of the power system, it's quite possible for the wind to actually reduce reliability. So this course will look at all of these issues, try to hit on some of the key elements of what's involved, perhaps indicate some ways of compensating, and in some cases look at the costs of compensating.